How are you guys? Welcome back to my YouTube channel. This is Nete Tarolo. We're still under open, we're still under the flow of water in open channels. Uh this is Fluid Mechanics N5. Um you can quickly, I'm doing an example from your textbook. This is page 25. I don't know if you have this type of textbook. Are you using this textbook, right? If you're using this textbook, we can go to page 25. Why I'm using this textbook for this intro is because I'm still under introduction. I want you to understand these examples. Go do this example with me as I'm going through this example so that you'll understand what is going on. So me, I will simplify them. I will explain them so that you understand what is going on here. Then, yeah, just stay tuned. Remember, what we will do, what we are dealing with. I did explain the first part. I hope you know the first part I did explain. Now we are here. This example one. This one here. And right. We are dealing with these examples. So I want you so that you will understand what is going on here. And then this is what they will use. This textbook is what they use, this textbook to set up questions. It's just that they change values, but it's one and the same thing. If you use this textbook and then you go with me, you understand it, already you've passed fluid mechanics. They won't ask you something from heaven or hell. They will ask you something that it's inside of this textbook. This is the right textbook for N6, this one. So I want you to go with me. I want us to go through these examples together. Quickly go to page 25 and let us check example 1. Before I create my own questions, but I want us to deal with this because I just realized they said more with this textbook. So let us go. Do not forget to subscribe. Also subscribe to my YouTube channel and like and comment and share this to your fellow classmates. Okay, let us go. Want you to understand this example, what is going on here. Okay, fine. They say calculate the ratio. Okay, they want us to calculate what ratio. What they want here, it is the ratio, but they did not state. Remember, if they cannot just say ratio. They can be ratio, they can be velocity ratio, rate of flow ratio. Ratios are many. Gradient, mean gradient ratio, so or area ratio is cross-sectional ratio or what. There are many ratios. Coefficient ratio will depend. Let us read and understand what actually is the ratio that is needed here. Is it calculate the ratio of quantities of water, quantity, okay, of water, remember, of water that flow through the laundry, that flow, remember, just check this, quantity, that flow, what is it? We're dealing with the pipe. Understand the question. That is why I want us to do this example together. I want you to understand here the quantities of flow of water, quantities of water that flows through the land, that flows, the quantity that flows, imagine it's a quantity that flows, imagine the quantity of water that flows. Remember, you have a quantity of water, imagine what? The quantity of water that flows, quantity. This is a quantity. Let's say I have a pipe, let me make it easy, like this. There's a water that is flowing here. The quantity of this water. The quantity of water that flows. Simple. When they talk about quantity of water that flows, they simply what they are talking about. It is Q. This is a quantity. Rate of flow. What is flow? You know that the quantity is something that when you have a pipe like this, remember you can calculate this quantity. You can calculate this quantity if the water travel this direction and discharges here. We can calculate the quantity because we remember that the rate of flow is measured in watt, right? Remember that. Then there's quantity. This is an quantity because they're talking about quantities of water that flows through. What is that flowing? Is a quantity, the rate of change. They did not say what the velocity, the quantity. What is quantity is this rate of flow, which is represented by what? Q. You know, the rate of flow. Simple like that. The quantity. Take note of this. Let us underline here. Of water flow through the laundries, because you see two laundries with the same inclination. With the same what? Inclination. Okay. What I want to underline here. Note this way, it's inclination. When you are dealing inclination in fluid mechanics, whether it's engineering science, whether usually let us focus in fluid mechanics because we're dealing with fluid mechanics, right? In fluid mechanics, when we talk about inclination, it's I. Remember, I. This is inclination, which is equal to gradient, is equal to inclination. This is the gradient. Declination is a gradient. This is what is also I. We know I is equal to sine theta. Well, we don't know that angle, which is I. I is equal to that sine theta because raised to the certain angle. I is equal to gradient. I is equal to the what? Inclination. Which inclination we know this is what? It's the same as what? Slope. I is equal to what? H over L. What is that? That is I. Coefficient, I. You know this. You must know this information. Oh, you must know this information. But this one, we'll use it when you have a pipe like this. Maybe it's inclined. Then there's an angle here. This angle is what we'll use. You're supposed to know that. Okay. Now, since we know this, that I here, this inclination is talking about the I, talking about gradient. You remember with the same I. They say it is the same. That means these objects have the same inclination or the same gradient and the same cross-sectional area. Right? Note, and the same cross-sectional area. This is important. You must underline this. The same cross-sectional area, same cross-sectional area, and the one lambda is semicircular. The one is semicircular and the other is square. Both have internal surfaces of the same roughness. Underline here. Same internal surfaces. When you open the pipe here, the internal surfaces of the same roughness. When you see internal surfaces, when they talk about the roughness, definitely roughness will bring. When you're talking about roughness, you must know that we're talking about what? When we're talking about roughness is either, we know that we get roughness is the shades. Shades is formal. Roughness, that means you're supposed, when you see roughness, when they say have same roughness, we're talking about what? The coefficient of shades. You know almost the coefficient of shades. Yeah, which is what? The coefficient of shades, the one. C. And also here, or K. Depend on the two, but most is this. C. Coefficient of shades. That means when you see the roughness is shades, is the constant of shades. They are talking about the constant of shades. Remember, when you are dealing with engineering science, remember when you did physics or what, remember when you're talking about the coefficient of friction, when they say there's roughness, when maybe there's a box, there's roughness, and then they are giving, also we have what, the coefficient of what, of friction, the roughness. Here is what, it's a shades. Here this roughness is shades, it's a coefficient of it's a Chase's constant. This is a Chase's constant. That means you're supposed to apply a Chase's formula somewhere, somehow. You must apply something that includes Chase's formula. Okay, 1, 2, 3. Then we are with same roughness. Let us deplete the structure first. Okay, they said now there are two about the flow, the water flow, they have on two louders with the same inclination. Okay, same inclination, the same cross-sectional area, lambda the same is the same. One is a semicircle here, one is a semicircle. You can say one is a semicircle like this, one is a semicircle, one is a semicircle, here is a semicircle. I just throw the 3D semicircle and R is a square. That means somewhere somehow here it's linked with what? With a square. Somewhere somehow here it's a square. What is flowing here? Somewhere somehow this thing is linked with what? This thing is a square. Here cross section is a water flow here, which is that contact. You understand? They linked the pipe. The pipe is start with cross section. When it's reached here, it's become what? The pipe changes to become that square. You understand? Yeah. That means the pipe start being the pipe first is a cross section of the square of the circle. Then it changes and it becomes what? A square. Something like this. On and on. But the section is the same. The cross section is the same. Yeah, I hope you understand that. Hope you understood that. You have to understand that. Okay, sharp. I have explained this. So, one thing is important. You must know the set. We calculate what the ratios. The ratio of quantity. The ratio of quantity, that means is Q. And as I said, the ratio of quantity, which is Q. Remember, ratio can be Q2 over Q1 or can be Q1 over Q2. Right? We want this. Is clearly we will use this formula because at the end we're supposed to find this, and then we know this. It's a ratio, right? And then we know because there is a roughness, we must take in consideration C. That means you know that Q will use this formula here. A multiply will be A multiplied by C I will use this formula. Why? We only use, actually the rate of change is what? Is area multiplied by velocity. But now because there's a roughness, we won't use this velocity. We'll use this what? Changes. We'll consider this changes constant. What? Remember, we use this formula now. We're supposed to apply what? This formula. We should use this formula. We were supposed to apply this formula here. Now, when do you apply this one? You apply if you have the same I. Remember, they say gradient. The inclination is the same. If you have the same inclination, also if you have the same roughness, which is K. You understand? Same area, but most will be this. If you have this thing, if this thing are the same, your Q is supposed to use this formula. If you have the same inclination I and changes constant, if it's the same, the roughness is the same, use that one. Do not use that. Do not use this that says Q is equal to A multiplied by velocity. Do not use this one. It's V. You're supposed to use this kind of thing. This one. Right? I hope you understood this. Now let us attack this question very fast. Let us deplete. We have a square, and when we have a semicircle, as it is written there. Right. Remember, from here until here, until there, it is D. From here until there, it is D, which is there up to here. From here until there, It is radius, which is r, right? This is a square. Also here it is d, or you can say l. It's up to you. You can say l. Right, this is a square. We have this type of two figures, these shapes, right? Now they say they want, we know we're supposed to calculate the ratio, but before we get to this formula, like Q is equal to area multiplied by C square root mi. You see, we're supposed to have to calculate this m. That's our goal. We're supposed to calculate this m. That it's our goal to have that m. Okay, let us start. We know m, hydraulic m is equal to area over p, where that perimeter. Okay, now let us treat them separately. So we have these two type of few figures. All right, now let me start by, let us calculate m of a semicircle first. Semicircular. Remember, we have two shapes, and today we have two shapes, this shape 1 and shape 2. Okay, let us start by this one, semicircular. We have a half. We have this shape. Let us start by this one. Now we know m of this one. We know that it's area over with a perimeter. Area, because of section, we know the area of a circle is pi over 4, right? It's pi over 4, but now it's half, will multiply by 2. It's pi over 4 multiplied by d squared multiplied by 1 over 2, because it's a semicircle. We divide by the perimeter. Perimeter, you know what is pi d, right? Because now it's a half, we multiply by 1 over 2. Simple, just like that. Multiply by would be p diameter multiplied by 1 over 2. Then mathematical, this and this will cancel. The 1 here will cancel. The pi and this. When you punch this on your calculator, you're supposed to get, when you simplify that will be 0.25 d. D in terms of m is for what? This is m. It's m for what? For semicircle. Calculated m. It is a m for semicircle. Right, it's a m for semicircle, that one. Since we have that m for semicircle, let us, it's a m for semicircle, right? That is the m for semicircle. Now let us, because we have two shapes, right? Let us, we're done with this one. We're done with semicircle. Let us check what a square, because you have two shape, square m. Now let us see at the side, this was this. Now let us deal with what? With a square. M of square will be area over p, right? And then we know this is L. L area will be L squared over perimeter. We know must be 3L, which this will be 0.33333 L. 0.33 L, right? This is m of what? M of square. M of semicircle. It's m of semicircle. We understand. M of square, then m of semicircle. Now we have that. But now we are done with this. But in terms of L, in terms of D, but what information we have also, we want, remember the areas. This formula has an area. We're supposed to calculate the area. This one we have is fine. What about the areas? Let us deal with areas. But they told us that the areas are the same, right? Remember, they said the areas are the same. That means if the areas are the same, area of square must be equal to the area of a semicircle, right? Area of square must be the same as the area of semicircle, right? It should be the same because they said, remember, same cross-section area. They have the same cross-section area. We know this is the same of the square. We know the area of the square already. We have calculated. We know the area of the square is this one here. The area of the semicircle is that one, right? So we know this of the square, it's L squared, right? Then what about of the semicircle? We know is pi over 8 because we multiplied it by 1 over 2, right? This will be 1 over 8 d squared, right? D squared, right? It's 1 over d squared. You understand that? We have these stuffs right now, right? Now, let's check. We have D. We can make D a subject or L. It's up to you. Let me just make L the subject. Or we'll take the square root both side. You know mathematics. You want L, make L subject. Take the square root both side. When you take the square root both side, we'll cancel that one. Will be pi over 8 multiply the square root and the square root cancels. This will be D. Remember, the square root, if it's squared, it will cancel the squared will cancel the square root. Will be left with D like this, right? Then you punch the calculator here. Punch this. Punch pi over pi. Right square root of pi over 8. This will supposed to give you 0.62667 D, right? This is what it's L. Now let's check on the formula where we have L. We want M, right? Now we want to find where we have L, right? Since we have L, we want what? M. We're supposed to have M, right? Let us find the M for the cross sections, what? Because what is needed is these are different. We have Q. This must be Q. Maybe it's a Q1 for circle, right? For the formula. Q1 maybe it's a rate of flow for circle, rate of flow for radius, but we want M's, right? Now, since we have this, we have the formulas, we made the formula the subject. Now we can find what M's there. We needed M, right? Our goal was to find M. Right now we have the M, we have this, but now we have what? L. L corresponding with this one, with this of the square. We know that mean gradient of the square is this formula 0.333 L1. We substitute, we take this L here, we substitute that, will be 0.33 multiplied by 0.626667D, right? Here it is D, 7D. Or let me write it here because there's too much space. I'm not supposed to squeeze that. When you substitute that, will be 0.333 multiplied by D here. You substitute that D here, will be 0.62667D, right? This is what? It's M. Remember, when you multiply that, you punch on your calculator, your M for square must be equal to M from square must be equal to 0.2087D, right? In terms of D, we're done with that. We have that in terms of what? In terms of D, we have M. Now let us apply our formula. You understand? Let us apply our formula. Let us apply the formula. Now we can find what the quantity. Okay. Let's check what is the. Now we can come here and use this formula. Q, right? This is Q. 1. Okay, we start with the smallest cross section. We know this. Let's check the when we have this one is bigger, this M is small, big. This one is a greater M, this one is a smaller M. Let's start with the big one. This will be Q2. You see Q2, which is a square. I can say Q2 over Q1. Let me write this rate of flow of a square. When I say this is square, is Q over of the what? Of the semicircle. Same. This is equal, we know the rate of flow is area multiplied by C, because there's a roughness, we'll use this formula, MI over area multiplied by C over MI. Okay, right. The cross section, they said the cross section are the same. A and A is the same. Remember, this is a square. I just say SQ. This represents a square. This the semicircle, because this M is big. Must be. See, this M is big. It's supposed to be on the top when you're doing a ratio. This M is a small. 0.25 is small to this. This semicircle must be on the bottom. The rate of flow, right? So this is the quantity. A and A must cancel because they say it is the same, right? A and A is the same. Same roughness. C is the same. This represents the roughness. As I depleted the roughness, C and C cancels, right? We'll be left with something like Q over Q of semicircle will be left with something like square root MI over square root MI, right? Square root MI over square root MI. But they say the gradient, the inclination is the same. I said the inclination is what is I. I is equal to the inclination. I is equal to what? To inclination. But we know that mathematical, this square root, if you have a square root, this will be square root of M multiplied by the square root of I. Remember the sets, the law of radicals. If you have, remember mathematical, if you have the square root of B multiplied by B, this is the same as square root of A multiplied by the square root of what? Of B. So we'll separate this. Let us separate that. Mathematically, Q of square over Q of same. This will be equal to mathematical, that is the same as square root of M multiplied by the square root of what? Of I, right? Over the square root of M multiplied by the square root of I. Remember, M did not say the mean gradient. This is not the same. We want it. Remember, they are not the same. As you can see, this thing 0.33 and 0.25 is not the same. That means M of the square, remember, says this is SQ. This represents square. This is semicircle. Are not the same. That means this and this you cannot cancel. Is not the same. But the roughness, but the gradient, they say with the same what? The same inclination. That this and this is the same. We cancel this. You understand? As we cancel that, we left with this formula: Q S of the square, right, over Q of the semicircle. We left with what here? It's M squared, M root M. This is for what? It's for square. It's for square over root M. This M is for what? For same circle, right? This is formula. Now we substitute what we have. We wanted to calculate, this is our aim. We have this A, this S, M of what? Of a, we have the S of the what? Of the square, the of the semicircle is this one. Semi. We have m of the semicircle. All they are in terms of what? Of d. This is in terms of what? Of d. Now we substitute to our formula. I've derived that formula. If you encounter such problem, use this formula. Straightforward. Use this formula. I have just simplified it. Now I hope you'll understand. Now let's come substitute here. We'll use that formula. Let me erase here on the top. Let me erase there on the top. Let me write this. I just write this. I translate this. I write it here. Q of what? Xq. It's a square over Q of what? Of semicircle is equal to the square root of m. This m is what? Is for square, right? Over the square root of m. This m is for what? Is for same, because they are not the same. If you can see the mean gradient of the semicircle, the mean gradient of square is not the same. Now let us substitute. We know m of this s of the square. We calculate it here. We substitute this, or will be square root. Will be the square root of what? If you multiply that, supposed to be the square root of the square root of this, ne? But now let me check. 0, 0. This is 0, 0.03, 0, 0. Okay, the smallest must be on the top. Remember. Okay, sorry here. Let me do like this. Okay, but it's fine. We'll interchange. Final answer, we interchange. Remember, we're supposed to interchange. We'll interchange the ratios. We will interchange the ratios, right? Because now we want to remember the question was saying the one lane, okay, square of water flowing through the, okay, now this is the formula. We have this. Let me substitute that is 0, 2087 what d over is q over q semi, right? Over what is this? Semi. Here we have this is square root of 0.25 d, right? Punch your calculate square root of this, square root of that. You plug that on your calculator. D and D must be cancelled, is the same, right? Then you've left with square root of 0.287 over square root of 0.25, right? This is q squared over q same, right? Then you punch your calculator there. Punch the calculator. Let me check my calculator. So punch the calculator. Want us punch this calculator. Here we have square root, right, of 0.2087 over square root of 0.25, ne? We left with this, ne? Right. Check the ratio q sq over q semi will be equal to 0.914, right? Because it's the ratio must be into 1, right? But now it's like this is to 1. It's like, now let us interchange. Take this on the top and take this on the top. Then when we interchange, we'll have q same. We'll have semi. A inverse, we take this on the top. Take that one on the top, will be q square. We take that on the top, will be 1 over 0.914. Right, you punch that on your calculator. When you punch 1 over 0.914, this will give you this value. When you punch, we'll have 1, we'll have 1,095 into 1. This is the ratio. That is the ratio into 1. And remember, the ratio must be into 1. This is the ratio. Why I did this? Let me cancel here. Why I did 2 ratios? It's either our ratios must be 2, ratio 1. These people, because they are not specific, ratio into what? Into 2. We don't know which one starts. The examiner, so as we can say, we can write the ratios. We have the ratio 1, Q of squared over Q of same, which is equal to 0.914 over 1, or we have this Q semi over Q squared, which is 1 over 0.914. Our ratios, it's either we have the ratio of 0.914 into 1, or the ratio of 1,095 into 1, because they did not specify which one the square is number, it's 1, or the square is the first. They don't tell us how did they align this, the sequence. They did not tell us. So guys, do not forget to subscribe. Stay tuned and stay aligned. Subscribe to my YouTube channel. Thank you guys.